If you need to draw a Bohr model of an atom, the thing that you need to do is you need to get a periodic table. If you know how to read a periodic table and follow along with some numbers and count, you can actually draw a Bohr model very, very, very easily. Now I will be honest with you. We were going through the history of an atom, and we first had Democritus. Democritus was the first one that said atomos. And with atomos, he just said that we have these little blank spheres. They are indivisible, so that's as small as it could get. John Dalton, if he wanted to draw an atom, it would be very similar because he actually borrowed a lot of Democritus's ideas. They were just these tiny, indivisible little particles. Well, then J.J. Thomson came along. When J.J. Thomson came along, he discovered the electron. And he just thought that these little electrons were just scattered throughout the atom in what he called a plum pudding model. Well, that actually wasn't really true either, because Rutherford came along. When Rutherford came along, he discovered the nucleus of the atom, which has the protons inside of it, and then he said that we had these little negatively charged electrons just scattered throughout. Well, from there, James Chadwick came along. Not only did we figure out that we have protons inside of the nucleus, we also have neutrons, and the electrons scattered on the outside. Now where we are in our little history timeline of the atom, which actually isn't the real case. I'm going to give you a little preliminary lesson here, but we have the little electrons scattered on the outside of the atom. But instead of just being scattered like this, Bohr, Niels Bohr, actually figured out that these little electrons are on these set paths. Now the set paths are not actually in little rings like this, like a hula hoop going around a little ball in the center. Instead, you have something that's 3D, kind of like this orange. And you would have electrons on the outside of this orange zooming around. And then around that, you might have something larger like a grapefruit, and then something larger and larger. So these shells are actually 3D. We just draw them in flat little in circles like that. Sorry. So this is where we're at in our history of the atom. In order to draw the Bohr model, the first thing that we need to do is figure out what element we want to draw. Let's say that we're drawing titanium. Titanium on the periodic table is number 22. That means that it has 22 electrons that need to go on these little rings on the outside, which are called energy levels. So I'm going to write down here that it is 22. Now, if we want to find the number of protons, electrons, and neutrons inside of that atom, you can do that. Protons is 22, electrons is 22. For your number of neutrons, you're going to take your mass and round it to a whole number, which is 48. You're going to subtract off 22. So 48 minus 22 is 26 neutrons. These 22 protons and 26 neutrons are stuck in the middle of the nucleus of the atom. So we just draw a little dot and say, hey, we've got 22 protons, 26 neutrons there. For your electrons, they need to go on these rings. Now the rings are the energy levels. You'll never have more than 7 of them. The reason why we'll never have more than 7 energy levels is because the 7 periods on the periodic table. So the periods, if we number them this way, 5, 6, and 7. Now remember, these two rows down here, if we follow the numbers, 55, 56, 57, 58 goes down here. So these are actually part of period number 6. Same thing with these are part of period number 7, 87, 88, 89, 90's down here. Goes across and then back up here to Rutherfordium. So if you're wanting to draw the number of energy levels, you're going to find your element on the periodic table, which is here, sorry, and it's in period number 4. That means that we're going to draw 4 rings surrounding the nucleus. It'll have 4 energy levels. Now with those 4 energy levels, we need to put electrons on those energy levels. And in the past, your teachers might have had you memorize how many electrons go in the different energy levels. And they just said, hey, it's 2, 8, 8, 18, 18, 32, and 32. but they never explain to you where those numbers came from. Well, if we look at energy level number 1 on the periodic table, or period number 1, we have 1, 2 elements. 2 electrons fit. The next 2 are 8. So we have 1, 2, 3, 4, 5, 6, 7, 8 in both periods 2 and 3. If we count across period number 4 and period number 5, there's 18 elements across. There's 18 and 18. Now these last 2 are 32 for 6 and 7. If you count across 55, 56, 57, down here to cerium, across to lutetium, back up here to hafnium, and keep going across to radon, there's 32 32 elements there. So these numbers you don't actually need to memorize, you just need to know how to count how many elements are across in the different periods. So all of the different energy levels are going to fill except what this outside ring, which is called your valence electron shell. So 2 are going to fit in that first energy level. And some teachers I know make you draw the little dots like this and have the 2 little electrons on there. I don't have you do that. You can just write the number 2 there. Now if you're not in my class, you might want to check with your teacher to make sure it's okay. But for my classes, I am totally fine with you putting a number 2 there, just saying that there's 2 electrons on that shell. Now the next shell is going to fill as well. There's 8 electrons on that shell. The next one is going to fill as well, and there's 8 on that shell. Now for this valence electron shell, you have 2 options here. You can take 22 and subtract off 2, and then subtract off 8, and then you can subtract off 8 again. Or you can do this the easy way. If we go to period number 4, when we go to period number 4, we just count over 1, 2, 3, 4. 4 electrons are going to be in that outside shell. If you do the math, so we have 20, 12, 12 minus 8, that's equal to 4. Those 4 are going to fit there as well. Either way, it's totally up to you how you want to keep track of how many electrons you have. But if you have to draw something like bohrium here with 107, that's a lot of math to do. It's very easy just to count across, jumping down here first, of course, and then back up to get to bohrium. So if we do another one, just to do another example, let's say we want to do tin. Tin is Sn on the periodic table. It is number 50, so we have 50 electrons that need to go in different shells. The first thing that we want to do is figure out how many of the different energy levels we want to draw. So tin here, we're going to cruise across, and as we cruise across, there's going to be 5 energy levels. So we put the nucleus there, that's where your protons and your neutrons live. 1, 2, 3, there's 4, 5 energy levels. For your 5 energy levels, we want to put the different 50 electrons on the different energy levels. We know that the first energy level is going to hold 2 electrons. The next one is going to hold 8, 8, 18. So remember it's 2, 8, 8, 18, 18, 32, 32. Now in the valence electron shell, what I'm going to do is I'm going to count, starting at the beginning of period number 5 with rubidium, I'm going to count over till I get to tin over here. So I just go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So there's 14 valence electrons in a Bohr model for tin. Now again, this isn't going to be the complete and total where we actually find electrons, but it's just where we're at currently in our little history lesson of an atom. And these are going to come into play and be very helpful to us in the next few units. That's why we're going to draw them.